So this is a review of some of the types of questions you'll see in our geometry unit lesson 1.04 for measuring length. So this lesson is basically all about measuring and the segment addition postulate. So I'm actually going to insert a page here and talk about one thing with you guys before we get started. So when you're talking about a line, you can break this line up into multiple pieces, right? We call those segments. So let's say I broke this line into 3 segments. All the segment addition postulate says is that you can take this piece plus this piece plus this piece, and when you add them all together, you get the whole line, right? And you're like, well, duh, Ms. Winslow, that makes sense, right? All the parts together add up to give us the whole. So we can look at this kind of from a basic standpoint. This is 2 length units and this is 5 units. Then the entire length of this particular piece of this line is 7 units. So the parts add up to the whole. And when we're talking about a number line, sometimes you guys probably remember that includes positive numbers and negative numbers, right? But when we're talking about distance and length, we're always talking about a positive value. So if I said, what is the distance between -2 and 0, you would tell me 2 units. All right, so let's look at some of the types of questions you'll cover in this lesson. This one says, which 2 segments have the same length? So all they've done here is they've marked some points for us, F, J, G, H, and I, and they want us to tell them which 2 of those segments have the same length. So I see lots of segments, right? There's FJ, JH, GH, HI, all these pieces, and then you can even look at the segment FG, FH, FI. So let's look at these pieces and see how many units they are. This one is 1, 2, 3, 4, right? Yep, this one is 4 units long. So even though we're in the negative numbers here, remember we're talking about length, and length is always positive. And GH is 1, 2, 3. Oh, I skipped JG. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9 units here. GH is 4. HI is 3. So when you look at this, the 2 segments that are the same length are the 4, right? We're talking about FJ and GH. And those are line segments, so we're going to use that little line above the 2 letters to notate the line segment. Sometimes you'll also see it with 2 little dots. That's being extra specific, but that is a line segment. All right, here's the next kind of question. Again, this one is asking about distance, the distance between S and T. So the one thing you want to be really careful about is looking at the scale of the given number line. Let me go back real quick. This one, I didn't even point that out, but they were going by 1, right? Units of 1. You can see this is from 0 to 5. So each tick mark was 1 unit. Here, if you take a close look, each tick mark counts for 2. So that could definitely trip you up if you're working a little bit too fast. You might know exactly what you're doing, but you get the question wrong because you just didn't realize the units were going by 2 here. So we're still going to count the units. I see 1, 2, 3, 4, 5, 6, 7, 8, right? But they're going by 2. So it's really, you can think of it as 2 times 8, which is 16 units. We can count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. Wow, that did not go around my shape, did it? 16 units. All right, so again, length and distance, you're basically just counting on that number line. And it's the whole idea that the parts equal the whole. So here's where we're starting to get a little more interesting, right? It says, what is the length of HN? So HN is this little piece right here. And all we know is that the entire length of this line is 38. But we have some really helpful information here, these little tick marks here. Those are math symbols to show us that those line segments are equal. So sometimes I'll come up here, you might see, 5 and 5, right? And you're like, okay, those are equal, they're both 5 units. Here, they're actually using just tick marks. Sometimes you'll see 1, so those are equal. And in this one, we're seeing 2. You can also use 3 or 4 or 5. And we're going to see these tick marks a lot in our class. We're going to see them with triangles to show that triangle sides are congruent. We're going to see them in quadrilaterals. We're also going to see them in angle measures. They look like this. They're little curved lines. So it's just a way to tell you guys, the reader, that those are equal. They don't tell you how much they are, but you know that they're the same. So if these two pieces are exactly the same, any ideas how you could figure out each piece? So as I'm kind of going through this with you guys, it's a great idea for you actually to pause the video and try to answer the questions on your own, and then you can click play and get the answer. So you can try that now. With this one, because each piece is equal, all we have to do is divide this number into 2, right? Because there's 2 segments. So 2, whoops, my pen just messed up. There we go. 2 divided by 38. 1 second. Let's get rid of that. Two divided by 38. And in this class, you guys can use a calculator the entire time. So there's no restrictions. There also were no restrictions last year in Algebra 1, so hopefully you're used to that. So you're welcome to just easily type this in your calculator, or we could probably do this one by hand. 2 goes into 3 1 time. Good old long division, right? Subtract. 2 goes in 18 9 times. So it's 19 units long. Each of these are 19 units because they have the same tick marks. And when you add them together, 19 plus 19 equals 38. That's the segment addition postulate. By the way, and we'll talk about this, but a postulate is just a fancy word for rule. It's a math rule. All right, here's our next one. This one tells us M is between points C and Q. So I don't know about you guys, but I'm very visual. So whenever I see just words, I'm like, okay, let me draw a picture. So I'm going to draw a picture of M between C and Q. It doesn't say exactly where it is, so I don't know. I guess I'll just put it here. It just says it's between them. And then it tells us CM is 17 and CQ, the whole thing, is 21. All right, so now this is the same idea, the whole segment addition postulate or rule, the idea that the pieces together equal the whole. It's just a little different because this time they give us the whole thing and they want us to find the missing piece. So you're kind of working in reverse. You might want to pause your recording, try to find the answer, and come back and check your work. So when you have a question like this, you can certainly put an X here for unknown, right? Like, oh, I'm trying to find X. And a lot of people like to work it the same way. They'll say, I remember the postulate, 17 plus X equals 21, right? The parts added together equal the whole thing. And now you have just a one-step algebra equation that you can solve for X, right? So remember, we want to get X by itself, so we can subtract 17 from both sides. And we would get X equals 4, right? 4 units. So we found that missing piece. Another way to do this, which again, some people prefer, it just kind of depends how your brain sees the problem. Is they're like, oh, well, I know the whole thing is 21 and this piece is 17, so I'm just going to take 17 away from 21. And I have 4 left, right? Which is essentially what we did over here. But you guys see the difference, kind of just the way that you think about it? It's also less steps to do this. But you'll hear me say this over and over again. I do not mind how you solve a problem as long as you get to the right answer. So I don't grade you on your process because I feel like that's real learning, that's real life, right? So however you best see it, I'm going to show you all the ways I know how to solve a problem, and then you can pick the one that that just feels best to you. And maybe you know a way to solve a problem that I don't. It happens, and that's awesome. You should share it with me. I would love that. All right, here's the last type of question we're going to look at. Again, they're giving us words, which a lot of people like, what? This is a math class. So let's go ahead and draw a picture. P is the midpoint of DE. So here's my line DE, and I'm going to write P. Now this time they tell us P is the midpoint. So that's a fancy word. It's definitely one of the words we're going to talk about, and you probably already learned in your lesson, midpoint means the middle, right? That prefix mid. So I did put P right in the middle of that line, and I'm going to label the parts that they give us. So DP is 3x plus 2, and DE is 10x minus 12. What is the length of DP? Okay, so we're looking for this length, right? And we know the whole thing. So this is very much like was it this problem? Yeah, the very last problem, where we knew the whole thing and we knew a part and we were looking for the other part. But this question doesn't give us any like values, right? They have x's, there's variables, so we're going to have to solve for that x. So the big clue here is this word midpoint. Remember, midpoint means the middle. So what does it mean for a line to be broken up in the middle? It means that the two parts are equal. That's what midpoint means. It means that this line is equal to this line. So we don't even need to know this value. We just know that it's going to be exactly the same as this. So if it's exactly the same as this, dp, well, dp is 3x plus 2. Oops. So I am going to label this line 3x plus 2. Because we know from the definition of midpoint, P is right in the middle, so that makes each of these parts congruent or the same. So, okay, if dP is 3x plus 2, that must mean so is PE. So that gives us some more information to try to figure out x, because now we can use the segment addition postulate. This piece plus this piece equals the whole thing. So let's just write what I just said. This piece, dP, 3x plus 2, plus the other piece, 3x plus 2, equals the whole thing, 10x minus 12. So you're actually going to find this a lot in our geometry class, where 10% of the problem feels like geometry, right? This segment addition postulate is geometry. And then now look, we've got it into an algebra problem, which I think is kind of fun. So now we just need to solve for x. This one has multiple steps, so we're just going to take it a step at a time. The first step would be to combine any like terms, right? You want to get everybody together that's the same. So then that's going to be the x values, and then any constant values, these just numbers here. So I'm going to work on each side of the equal sign to kind of get things cleaned up. So 3x plus 3x is just 6x, right? And 2 plus 2 is 4. So it's starting to look a little better. I'll forget that one. All right, so now our main goal is to get x all by itself. Well, x lives in two places, here and here. So we need to combine these x's, right? So we need to move one of them to the other side. It's up to you. We can move the 6x over to join the 10, or we can move the 10 over to join the 6. I kind of personally just keep the x's on the left-hand side, but again, it's totally up to you. So I'm going to move the 10x. People might be yelling at me now because that's going to make it negative, but that's okay. 6 minus 10 is negative 4x. I'll bring down this 4, bring down the equals, and bring down the negative 12. All right, almost done. The goal is still to get x by itself, so let's move the 4 over. We changed that sign, right? The opposite of plus 4 is minus 4. So we get negative 4x equals negative 16. Last step, this is negative 4 times x, so we're going to do the opposite, which is divide. Ta-da! You get x equals a positive 4, right? Because negative 16 divided by negative 4 is a positive 4. So be careful though, because we're not quite done, right? This one said, what is the length of dp? But we found a very important piece of that. We needed to find x. So x is 4. So all we have to do now is take that x value and plug it in for dp. So dp equals 3 times 4 plus 2. The answer is dp equals 14 units. And that's it. We can stop there. We have some other parts of this line that we could find, but it didn't ask us to, right? The question was just find the length of dp. So I hope this helped you guys out a little bit. You guys can always find more practice in our lessons. This was our review on measuring lengths in 1.04.